Hello all, I'm Scott Moore, Senior Technical Account Manager supporting Hewlett Packard Enterprise here at Ingram Micro. In this presentation, I'm going to review the components of data center infrastructure. So to start off, let's define what we mean by data center. For our purposes, it's going to consist of three things. It's the compute and storage resources consolidated for ease of management and power utilization. It's the networking resources that connect everything together. And it's the power, rack, cooling, software, services, and support infrastructure necessary to keep all those resources available. So when it comes down to data center components, we've already talked about the big three in a series of separate presentations: servers, storage, and networking. So we're going to talk about the rest of the elements here. We're going to talk about power, rack, cooling, server operating systems, and services and support. When it comes to power in a data center, there's many different things that need to be considered or established first. Most data center equipment runs on alternating current or AC voltage. In the US, we consider 100 to 120 volts to be low voltage, while 200 to 240 volts is considered high voltage. The power supplies in many data center products support either, but that's not always the case. High voltage devices can also be single phase or three phase. Single phase is the type of devices that have regular plugs that you can plug into outlets. Three phase are powered by three overlapping single phase signals and require an electrician to hook up to the power feed that you get directly from your utility company. Because they're hooked up by an electrician, three phase generally does not necessarily have a plug on it, but may very well just have several loose wires hanging off the end. In the telecom world, most systems, including landline telephones, run on 48 volts of direct current, or DC. DC power is just like what you get from a battery. It's constant as opposed to the fluctuating AC power you get from wall outlets in your home. In a data center, it's pretty common for devices to have redundant power supplies, meaning that each device will have two power cords that need to be plugged in. If a power supply fails, or a power cord becomes unplugged, or a circuit in the building is lost, the remaining power supply will keep the devices running. Many data center equipment manufacturers offer their own power solutions, but we also carry a broad line of power products from APC, Belkin, CyberPower, Eaton, Triplite, Minuteman, and Vertiv. At the bottom of the slide, there are several common sets of plugs and receptacles shown. The two main standards for plug types are IEC standards and NEMA standards. NEMA plug and receptacle types are defined by the voltage and the current used. For example, a NEMA 515P and a NEMA 515R, pictured here, define both the voltage and the current, because the 15 is the maximum amount of current in amps that can travel across that connector. The 5 in front of it, the 5- signifies it is low voltage. If it was a 6-, it would be high voltage. If it was a 15-, it's typically a three-phase high voltage. IEC plugs, which you see in the middle and the right side of the screen, are defined only by current. So the same plug and receptacle types can be used for high or low voltage, which is why you typically see those on the back of data center equipment or on the back of monitors that are both 110 and 220 compatible. They don't care what you're going to plug it into for a power source. With NEMA plugs, the fact that the connector ends in P means it's a plug and it's male. The fact that it ends in R means it's a receptacle and female. In the IEC world, females are odd. So the C13 and the C19 are the female receptacles for the adjacent numbers that are male. The C14 plugs into a C13, the C20 plugs into a C19. C19s and C20s support a max of 10 amps, doesn't matter if it's high or low voltage. Max of 16 amps, and the C13, C14 support a max of 10 amps. Uninterruptible power supplies are essentially old style car batteries in a box. They used to be lead acid batteries, just like car batteries used to be. A lot of them now are starting to switch over to lithium-ion batteries, the same types that you have in most notebook computers. The UPS is intended to give you enough power to shut down the equipment that's attached to it gracefully in the event of a power issue. They are not meant to take the place of generators. If you want something to keep your computer equipment up for a day should you lose power, you want a generator. If you live in an area where you have a lot of brownouts or blackouts that last for a short while, and that you don't want your computers to just shut off in your data center when you have a power drop like that, you'd like to have enough power to keep them going for a few minutes so users can close their applications and the servers can shut down gracefully and not lose data. That's when you want an uninterruptible power supply. Uninterruptible power supplies typically give you between 15 and 20 minutes of runtime for the equipment that's attached to it. There are outlets directly on uninterruptible power supplies that you plug your equipment into, and then you plug the UPS into a wall. And the wall power, when it's functioning, keeps the battery inside charged, so it's there and fully charged when you need it for a shutdown. Typically, though, a lot of the larger uninterruptible power supplies will not only have outlets you can plug equipment into, but they'll have high current connectors where you can attach a PDU. Usually because of the weight of UPSs, they go into the bottom of a rack and serve as a secondary ballast. It might be hard to get equipment at the top of the rack to have power cords to stretch all the way to the bottom. So what a lot of people do is rather than plug their devices directly into the UPS, they'll plug power distribution units or power strips into the uninterruptible power supplies, have those maybe along the side or the back of the rack, and then plug all their equipment in the rack into the PDUs, which are then plugged into the UPSs. So let's talk about power distribution units a little bit. Power distribution units, or PDUs, are for consolidating and managing power cords. These are very similar to the power strips you might have in your kitchen or your living room. The difference is in your house, you typically have a NEMA 515 plug, which would go to your wall outlet, and you have a bunch of 515 receptacles along the power strip. So you can essentially plug the power strip into itself. That's because the 15 amp connector is common in American residential areas and homes, but most of the devices we plug in, lamps, can openers, microwave ovens, things like that, don't draw anywhere near 15 amps. So it's fine to have several of those low power devices plugged into a power strip that only pulls or is only capable of pulling a max of 15 amps. That's not the case in the data center. So you'll see the outlets on PDUs are typically very different than the plug on the PDUs. And that's because the devices in the data center may pull upwards of 10, 11, 12, 13 amps sometimes. So you need to have a high current connector on the PDU to plug it into a larger line, maybe a 40 amp line, maybe a 60 amp line, to supply power to all devices that are plugged into the power distribution unit. As I mentioned, they typically support high current loads. That's why you have the high current connectors and high current plugs on power distribution units. So let's combine those together. We're going to have some data center equipment. In this case, I have two servers shown on the slide. Could very well be a couple servers, could be storage, could be high-end network switches, could be a mix of any of those. But our first step in power is to make sure all that equipment has redundant power supplies. Because I don't want a single power supply failure or cord being pulled out or a circuit failure to take down my data center. So redundant power supplies in all my equipment, whether it's server, storage, or networking. Those redundant power supplies, I'm going to connect to PDUs, power distribution units. And in this case, you'll notice I have the ones on the left to a left PDU and the ones on the right to a right PDU. I do not want to plug all my redundant power supplies into the same PDU because that defeats the point of redundancy. If I have redundant power supplies and they're all plugged into one PDU, if something goes wrong with that PDU, it doesn't matter that I have redundant power supplies. If I plug everything into the same source, nothing is redundant. So I'm going to have multiple PDUs. In this case, I can do all the power supplies on the right side of all my equipment to one PDU and all the power supplies on the left side of my equipment to another PDU. That works fine. Just make sure you size the PDUs appropriately. The PDUs then I'm going to plug into uninterruptible power supplies. And yes, the same thing here. I'm not going to plug the two PDUs into the same uninterruptible power supply because that doesn't give me any redundancy. If I have a problem with that UPS or the cord going to the UPS or the circuit a single UPS is plugged into, it doesn't matter that I have redundant PDUs or power supplies, everything is going to die. With this example, I have half of the power supplies in each data center product, my servers, my storage, my networking, attached to different PDUs going to a different UPS. And then finally, you want to make sure those UPSs are plugged into different circuits in your data center. Because again, if you plug them both into the same circuit, the fact that you bought two UPSs, two PDUs, and two power supplies for each piece of data center hardware you had, it was kind of a waste of money if you end up plugging them into the same circuit. You want everything for full redundancy, you want everything to be separated and no cross between any of the components, the power supplies, the PDUs, the UPSs, or the circuits that are powering them. So from this example, everything that you see here, your stacked servers, your PDUs probably on the sides, UPSs in the bottom, this is everything that would fill out your racks in a data center. It's kind of your standard layout. You want your PDUs in the sides or the back, so equipment from the top to the bottom can plug into the PDUs. You fill up the center of your rack with all your data center equipment, your servers, your storage, your networking, and you put your UPSs at the very bottom to serve as ballast. And all that goes inside our racks. Racks, fortunately, in the data center world are industry standard. They're all 19 inches wide between the internal posts. So anybody's piece of rack mount equipment will go into anybody else's rack, which is a nice thing in this industry. Typically, the standard rack is a 42U rack. And by 42U, I mean that you have 42 rack mount units of height to a rack, and a rack mount unit of height is 1.75 inches. And again, that's industry standard. So anybody's rack mount equipment will be some multiple of 1.75 inches tall. A 1U server will be 1.75 inches tall. A 2U server will be 3.5 inches tall, etc. The common sizes for racks: 14U is about the height of a desk. 22U is about the height of a countertop or a bar. 36U is about the height of a person. 42U, which is the most common, is the height of a door frame. And that's why it's the most common. You can wheel a 42U rack under a standard size door. 47U and 50U racks do exist. They are typically considered wall height in a standard structure. So they will go from the floor to the top of the ceiling. The reason those are not commonly used is because you can't get them under a standard door. If you're going to have 47U or 50U racks, you need to have a door on your data center that is 47U or 50U tall that leads right out to your loading or your receiving dock, or multiple doors. All the doors along the way to your receiving dock essentially have to be 47U or 50U in height, which is a non-standard door. These things are massive enough, typically between 350 to 550 pounds. You are not going to tilt them and gently slide them under a door at an angle. They do have wheels on them to move them into place. But again, you're not going to tilt them and take that weight off of 4 wheels and put it onto 2, because you will crush the wheels and then the rack will crush you. Different options to go into racks. We do have things like blanking panels to cover up the holes in the front of the rack where there isn't a piece of data center equipment installed, to make sure the air flows correctly from front to back, cooling the equipment that's in there. They do have KVM switches, so I can get a switch box, attach it to a single monitor, mouse, and keyboard, and plug it to all the servers in my rack, and then toggle between them with only a single keyboard, mouse, and monitor, so I don't need to have one of those for each server in my rack. Things like locking drawers, light kits, temperature monitors, humidity monitors, ballast kits If you're not using UPSs, there are separate weighted kits you can install on the bottom of your rack to prevent the rack from tipping should you want to pull equipment out to service it. And there are things called plinthing kits, which some people refer to as earthquake-proof kits. I don't like that term because to me, a plinthing kit just means that whenever they find your rack after an earthquake, a piece of your office building is still attached to the bottom of your rack. Plinthing kits allow you to essentially bolt your racks to the floor of your data center. So it gives you a little bit more stabilization. In areas like the eastern United States, which are not prone to earthquakes, they will keep it relatively stable for the kind of earthquakes we find on the East Coast, things that are below 4.0. A plinthing kit will keep a rack pretty steady. In areas like California on the West Coast, where earthquakes of 5 or greater are common, most of the architecture is designed to resist earthquakes of 4.0 or less anyway, so you shouldn't have a problem. However, plinthing kit gives you a little bit more added security. If the earthquake is severe enough, though, there is no guarantee and there is no earthquake proofing your rack by simply using a plinthing kit and attaching it to the floor of your data center. Manufacturers of this equipment, all the big OEMs, people like Hewlett-Packard Enterprise, Dell, IBM, Lenovo, they do make and sell their own racks. Ingram Micro does sell other manufacturers who sell racks as well, such as APC, Belkin, Eaton Triplite, Supermicro, and Vertiv. In addition to racks, they also make many rack accessories and cooling options. Talk a little bit about cooling. Cooling can be accomplished a couple different ways. The most common is using fans and cold air to cool your equipment. In many data centers, especially ones that are kind of like stuffed full of really hot equipment, such as like blade servers, chassis-based servers, things like that, you may actually find chilled water or other liquid-cooled mechanisms for reducing the heat. The rack shown here actually has a right and a left side. The right side of this rack holds all your data center equipment. The left side actually has a refrigeration unit. You attach this to a water feed in your data center, which also sounds slightly risky, but water will circulate through the refrigeration unit, circulate around the equipment through closed tubes on the right side of the rack, absorbing the heat from the equipment, getting it cooled through the refrigeration unit again, and then surrounding all the equipment with cold water again. APC, Belkin, Eaton, Triplite, Supermicro, and Vertiv, again, they all make cooling options for standard racks, as do most of the server and storage OEMs that Ingram Micro sells. I should also mention the placement of racks in your data center can also help with the cooling. A lot of people will do what they call a hot aisle and a cold aisle. So between every row of racks, you'll have one aisle that's cold, one aisle that's hot, one aisle that's cold. And the idea being in the front, I'm going to have all the air conditioners put cold air down my front aisle, which will be pulled in through the front of the racks and exhausted out the back. So that next aisle is going to be hot. The next row of racks essentially is backwards from the first row of racks so that their heat exhausts into that same aisle. And that's where you have the air returns, pull up all that hot air, send it back to a refrigeration unit, and use it to cool every alternate aisle. So the aisles where you see the front of the equipment should be cold. The aisles where you see the back of the equipment and the cables and the power supplies, that should be your hot aisle. Server operating systems. Few different ones that you've probably heard of in reference to servers. These are not desktop or notebook operating systems. You wouldn't find these installed on a desktop or notebook usually. You wouldn't want to install these on a desktop or notebook usually. Microsoft Windows Server 2022 or 2019 is still around and still used prevalently. Red Hat Enterprise Linux and SUSE Linux Enterprise Server are the most common ones. The reason you won't find these on desktops and the reason you wouldn't want to install them on a desktop or notebook is you may look at, maybe you have Windows 8 or Windows 10 on your desktop. You say, hey, Windows Server 2022 just came out. It's fairly new. It's probably the better performing one. I'm going to put it on my desktop and things are going to go a lot faster. And they won't. And the reason is desktop operating systems are very different from server operating systems. Desktop operating systems are written to take input from a keyboard and a pointing device. They're meant to be used by a single user who is sitting at the device, and the primary means of communication with the operating system is by typing on the keyboard and moving and clicking the mouse. That's not true of a server operating system. Server operating systems, there typically isn't somebody sitting there working on the server. You have people out across your production network who are sending signals over the network. So server operating systems are optimized to listen to the network interface cards for signals, and they're not optimized to take input from a keyboard or mouse. So when it comes to serving large numbers of people, server operating systems are great because they prioritize the information and the requests coming in over the network. They don't care about a user sitting there typing on the server because there really shouldn't be anybody sitting there typing on the server. It's not like you're going to be running Office or surfing the web from your server. It's meant to be done from a client system. In addition to these server operating systems, there's also a special type of operating system called a hypervisor. Hypervisors are used for virtualization, which is something that gives you the ability to run multiple operating systems on a single piece of hardware at the same time. We'll have a separate video on the basics of virtualization coming up as well. So hypervisors, the common ones, Citrix has a hypervisor, just called Citrix Hypervisor. Used to be called Zen. Yes, Zen Server was Citrix old name for their product. Microsoft has one called Hyper-V. Nutanix has one called Acropolis. Red Hat uses a industry standard open source tool called KVM, kernel-based virtual machines for their virtualization. And then the kind of standard, the long-running one when it comes to hypervisors is VMware, who has a product called vSphere or ESX or ESXi. Finally, I want to talk a little bit about services in relation to data center. Ingram Micro does have integration services, which will allow you to buy several products from Ingram Micro's inventory, and rather than receive a box with a server, 10 boxes, each with a piece of memory, second processor, and yet another box, 10 hard drives in separate boxes, our integration services department will integrate all that stuff into the server that you purchase, test everything to make sure it functions correctly, and then ship you a fully configured server after testing it. So all you have to do is take it out of the one box and plug it in. We have a professional services group, which offers many different services, things like infrastructure assessments. If you want somebody to kind of evaluate a current data center and see what they might be able to migrate to, we have assessments that will allow that to be done. We have asset disposition services for people looking to get rid of old data center equipment and to do it correctly, make sure drives are wiped of data, make sure things are handled in an environmentally friendly way. We offer those services as well. On-site installations are frequently offered by data center equipment manufacturers. They're also offered through Ingram Micro Professional Services. So if you need an installation for a piece of equipment done as the reseller and you don't have staff in that area, or it's a piece of equipment that you're not really familiar with, something unusual, our professional services staff can get somebody to install those on your behalf at a customer's location. We also offer warranty upgrades. Pretty much all the OEMs who sell data center equipment also sell warranty upgrades. 7x24 is very common in the data center environment because, again, for client systems, 9x5 next business day might be fine. At the end of the day, you're not going to touch the system again until you have to go back to work. Servers, those things are always running. So you might want somebody come out and fix it if it dies at 2 a.m. on a Sunday morning. 24x7 is very popular when it comes to data center equipment. We also offer third-party warranties by companies like Axiom, and professional services. So if you have servers or data center equipment that you need to extend the life on, maybe it's out of its original manufacturer warranty, but you want to keep it running and in production for a couple more years, we do have options for you as well. We also have custom contracts. So for certain manufacturers, and this is vendor specific, if you want the vendor to come out and provide a service, such as not only just on-site installation, but maybe you want a quarterly firmware update done, or you want to migrate from Intel networking to NVIDIA networking or something like that. Those kind of custom services, a lot of manufacturers can provide on a contract basis, which is also handled through Ingram. Finally, we also have service credits from some of our manufacturers. The nice thing about service credits is you can buy them now and then cash them in for services later. Where that's beneficial is especially in budget situations where I have X number of dollars budgeted for services this year. I didn't use it all. If I don't use it by the end of the year, it goes away and my budget will probably be reduced by that going forward next year. With service credits, you can buy credits now and then decide down the road, hey, you know what? I heard there was a critical patch to the software. I heard there was a critical firmware update. I would like HPE or whoever I bought the credits from to come out and provide those services for me. And you don't have to pay for it at that time. You essentially just pay for it out of the credits you previously purchased. So that brings us to the end. I hope that information was useful. If you have any questions on data center infrastructure, need any parts or assistance in configurations, please reach out to the Solution Design and Services team. Thank you much for your time.